Okay, welcome. This is 9.3 Law of Cosines. We use Law of Cosines to solve the remaining cases 3 and 4 for our oblique triangles. Case 3 deals with side angle side. Case 4 deals with side side side. Okay, and Law of Cosines is definitely way easier than Law of Sines, but the formulas are definitely a lot more to work with. Okay. So the law of cosines, which is given down below, for a triangle with sides A, B, and C and opposite angles A, B, and C, respectively, there's the formula to solve for side C, there's the formula to solve for side B, and there's the formula to solve for side A. These are the formulas we will use to solve for sides A, B, and C. Now, what if you want to solve for angles A, B, or C? Well, this means you would have to rearrange the formulas, which I've done for you already, so saved us some time. So if you rearrange these formulas, which means the first one on the left is for angle A, if I go ahead and rearrange this to solve for angle A, we'll get that A equals the inverse cosine of A negative A squared plus B squared plus C squared over 2BC. Angle B, inverse cosine of negative B squared plus A squared plus C squared over 2AC. And for angle C, inverse cosine of negative C squared plus A squared plus B squared over 2AB. So this will help us all solve for angles A, B, and C. So we'll use these three formulas. And then these three above will help us solve for A, B, and C. So let's go ahead and try them out. I mean, this is purely computational. Okay, so solve the triangle A equals 2, B equals 3, C equals 60 degrees. Okay, well, let's see what we have enough information for. Do we have enough information to find side C? Let's see. Side C needs sides A, B, and angle C. So we have A, B, and angle C. So this means that we can go ahead and solve for side C first. So let's say side C. And from the formula above, we know it is as C squared equals A squared plus B squared minus 2AB cosine C. Okay, and now plug in your numbers. C squared equals 2 squared plus 3 squared minus 2 times 2 times 3 times the cosine of 60 degrees. Make sure your calculator is in degrees. All right. I'm going to type everything in the right side into my calculator. So just, hang on, let me turn my light on. There we go. Too dark. Okay. So I'll type everything in on the right side just as I wrote it into my calculator. So 2 squared plus 3 squared minus 2 times 2 times 3 times the cosine of 60. And I get 7. Then square root both sides. And we'll get C equals 2.65. Normally you'd get plus or minus 2.65, but since this is looking for a side, it's looking for a length, we only want the positive value. So we'll only take positive 2.65. So 2.65, there's side C. Okay, Well, we have side A, we have side B, we have side C, we have angle C. This means all you have to do is look for angle A and angle B. So that'll be your next one. Let's look for angle A. All right. Angle A. So A is given as the inverse cosine of, and what do we have above for A? Negative A squared plus B squared plus C squared over 2BC. Okay, I think I got that. Negative A squared plus B squared plus C squared over 2BC. Okay. And then you get A equals the inverse cosine of, so A was 2, so I'll get negative 2 squared plus 3 squared plus C, which is my 2.65, plus 2.65 squared all over 2 times B times C, 2.65. Okay. And now, type this in your calculator exactly as I wrote it, right? Parentheses you will need. Okay, just to show you what I'm typing in, I can actually share my screen. Let's see, go here, boom, look at that. Okay, so I need to be in degrees, perfect. So I'm gonna say second inverse cosine. Oops, no, that's not it. Don't need to do that. Okay, inverse cosine, fraction, negative parentheses 2 squared plus parentheses 3 squared plus parentheses 2.65 squared over 2 parentheses 3 parentheses 2.65. Close this whole parentheses. There it is. That's how you type it in, exactly like I wrote it. If you mess up a parentheses, you might mess up the whole thing. And make sure you are in degrees. So we get that A is approximately 40.88. 40.88 degrees. Okay, that's how you type it in. Nothing to it. All right, let's go back to my screen. There's me, there's me, there's me. Boom, boom. Okay, perfect. So you have side C, you have angle A. Now all we have to do is find angle B. That's it. And that's going to be really easy because angle B is going to be 180 degrees minus 40.88 degrees minus 60 degrees. So 180 minus 40.88 minus 60. You get 79.12 degrees for angle B. That's it. Nothing to it. See? Law of cosines is easier, but again, heavier in the computation. Okay. Cool. Let's do another one. All right. B is 1, C is 3, A is 80. This means that we are given enough information to find side A. Given enough information to find side A. So that's where we'll go. Side A And we have that A is B squared plus C squared minus 2BC cosine A. Let me just verify. A squared is B squared plus C squared minus 2BC cosine A. Got it. Okay, well, we have all that information. Plug it in. A squared is 1 squared plus 3 squared minus 2 times 1 times 3. 2 times 1 times 3 times the cosine of 80 degrees. Okay, let's see what we have. 1 squared plus 3 squared minus 2 times 1 times 3 times the cosine of 80. And we get that A squared is 8.96. 8.96. Then square root your answer. And we get that A is 2.99. A is 2.99. Okay. So we have all three sides. We have angle A, which means all we have to do is find angle B and C. So let's find angle B. B is given by the inverse cosine of, and what is it? Negative B squared, A squared, C squared over 2AC. Okay. Negative B squared plus A squared plus C squared over 2AC. Okay. Plug in what we need. B is the inverse cosine of, what do we have? 1. So negative 1 squared plus A, which is 2.99 squared, plus C, which is 3 squared over 2 times 2.99 times 3. There it is, 2 over 2.99 times 3. All right, this means that B, and again, type it in the calculator just as I wrote it. Inverse fraction, negative 1 squared plus 2.99 squared plus 3 squared over 2 times 2.99 times 3. We get inverse cosine is 13.20 degrees. There's angle B. Or did I miss one? Nope, yep, I missed a 9. Let me see, 2.99 times 3. Oh, see, that threw everything off. Don't miss a 9. 2 times 2.99 times 3. Yeah, this is actually 19.22 degrees. I typed in 2.9. I forgot the other 9, so make sure type in 2.99. Okay, there it is. And now, well, all you have to do is find C. So for angle C, C is going to be 180 minus 19.22 minus 80 degrees. And C is going to be 80.78 degrees. All right, not bad. Okay, let's keep going. All right. So those were side angle sides. Now this is side, side, sides. So we're given A, B, and C, which means we have to find angles A, B, and C. So that's where we'll start. So for angle A, right? A is given by the inverse cosine of negative A squared plus B squared plus C squared over 2BC. So just plug everything in. A is equal to the inverse cosine of negative 4 squared plus 3 squared plus 6 squared over 2 times 3 times 6. All right. And get the inverse cosine of negative 4 squared plus 3 squared plus 6 squared over 2 times 3 times 6. And I get that A is 36.34 degrees. Okay, then find B. Angle B. B is given by the inverse cosine of negative B squared plus A squared plus C squared over 2AC. Plug it in. What do I have? 4, 3, 6. Okay. So negative 3 squared plus 4 squared plus 6 squared over 2 times 4 times 6. All right. Second, inverse cosine, negative 3 squared plus 4 squared plus 6 squared over 2 times 4 times 6. We get that B is 26.38 degrees. Okay. Last one, find C. That one's the easiest, right? For angle C, C is 180 minus 36.34 minus 26.38. And C will be 180 minus 36.34 minus 26.38. We get that C is 117.28 degrees. Bam. Okay. One more time. There's A, B, and C. So let's do it. Angle A. Cosine inverse of Negative a squared plus b squared plus c squared over 2bc. A is the inverse cosine of negative 12 squared plus 13 squared plus 5 squared over 2 times 13 times 5. All right. And now A, let's see, inverse cosine, negative 12 squared plus 13 squared plus 5 squared over 2 times 13 times 5. A is 67.38 degrees. Okay. B. Angle B, given by negative b squared plus a squared plus c squared over 2ac. This means B is the inverse cosine of negative 13 squared plus 12 squared plus 5 squared over 2 times 12 times 5. So inverse cosine, negative 13 squared plus 12 squared plus 5 squared over 2 times 12 times 5. Hey, look at that. This is exactly 90 degrees. Well, that could be because the sides are a 12, 13, 5. So that is a special right triangle, 5, 12, 13. Okay, and of course, angle C. (180 minus 67.38 minus 90). 180 minus 90 minus 67.38 and 22.62 degrees. Boom. Okay. That is how you work the law of cosines. As long as it's a case 3 and 4, you're good to go. Okay. Like I said, strictly computational. Yeah. All right. Word problems. A motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away, maintaining a constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents. The crew finds after 4 hours, the sailboat is off course by 20 degrees. How far is the sailboat from Key West at this time? Okay. So we are leaving from Naples, Florida. So I'm just going to draw a diagram here. So we'll call this up here, Naples, Florida. Yeah. Whoops. Go back. Whatever. So this point will be Naples, Florida. And then we are going to Key West at this time, wherever Naples, Florida is, right? So we are headed down to Key West. Which is 150 miles away. All right. So that's 150 miles away. All right. So maintaining a constant speed of 15 miles per hour, they encountered heavy crosswinds, and after 4 hours, the sailboat is off course by 20 degrees. Okay, so this means that how far are they? Well, if they're going 15 miles per hour for 4 hours, they have traveled 60 miles so far. So this means that our boat, let me see, zoom in a bit. There we go. So our boat is off course by 20 degrees, right? So, and if they traveled 4 hours at 15 miles per hour, they've traveled 60 miles so far, okay? They've traveled 60 miles so far, okay? So that answers A. Now, the boat's gonna keep going this way, but they need to find out what angle you need to turn to correct and get back on course for Key West. So we need to get back here. Okay. So here's my boat. We're going the wrong way, right? We're going away from Key West, and we found that we're off course by 20 degrees. So this means that this angle is 20 degrees. Okay. So with that being said, we need to know at what angle should this boat turn to get back on track, right? What angle should we turn at? So this means we are looking for this value of theta. And in order to find that value of theta, well, we need to know what this value of theta is. So that's going to be our first step. And then as well, after we get back on course, we're going to need to know how far are we from Key West still. Okay, so this is everything that we're looking for. So let's put some labels on stuff, right? So let's say that this 60 miles, we'll name it B, and this 50 miles, we'll name it C. Okay, so the first question says, through what angle should the sailboat turn to correct its course? So this means that we're gonna look for that blue angle of theta first. So that's gonna be our first problem. We're gonna say, for B, find theta, right? We're looking for this theta. Okay, so to find that theta, well, this means that if that theta is there, then to find it, well, if the side is C, so we can also consider this angle as big C, just to relate it to our formulas, right? So to find this angle C, we know that it's given by the inverse cosine of, and you're gonna have negative C squared plus B squared. I labeled that X. So actually let's just relate to everything to the formula. Whoops. Stop it. Let's label this side A. That'll work. Okay, so this would be negative C squared. We can't use this because we're gonna need A squared, and we don't know A squared just yet, right? We don't know A squared just yet. But do we have other information? Yeah, you can actually find A because we're given angle A. Okay. So this means that we can actually find side A first before we find theta, because we're going to need A first. Okay, so let's backtrack. So we're going to say find side A. Okay, find side A. So this means that A squared is given by B squared plus C squared minus 2BC cosine A. There we go. Which means I'll get A squared, which is equal to 60 squared plus 150 squared minus 2 times 60 times 150 times the cosine of angle A, which is across from A, which would be 20 degrees. So this will give me 20 degrees. Okay, let's type everything in. So 60 squared plus 150 squared minus 2 times 60 times 150 times the cosine of 20. I get 9,185.5. And then square root that answer, and we get A is 95.84. And this is in miles, nautical miles. Okay, so now we know side A. So side A is 95.84 miles. Okay, which means now we can solve for blue theta, and once we find blue theta, we can find red theta, or pink theta, whatever color it is, right? So this would be C. Find theta, blue theta, right? Or we're calling it C, right? Find angle C. Okay, so with that being said, to find angle C, we know it's given by the inverse cosine of negative C squared plus A squared plus B squared over 2BC, not BC, 2AB. Okay, then plug in all the information we know. C is the inverse cosine of, and let's look at our triangles so we know what to use. I'd get negative, so side C is 150, so negative 150 squared plus A squared, which is 95.84 squared plus B squared, which is 60, over 2 times A, 98.4, times B, which is 60. All right. Okay, and let's calculate. Negative 150 squared plus 95.84 squared plus 60 squared over 2 times 95.84 times 60. And we get that C is 147.64 degrees. Okay. Which means that we can now find our angle of theta, the red angle, because these two angles, believe it or not, make how many degrees? These two angles make 180 degrees. So, to find the way the boat has to turn to get back on course is, for D, we'll call this step D. We'll say find red theta. And we know that this theta is going to be given by 180 minus 147.64 degrees. And we have to turn an angle of 32.36 degrees. So that's the angle they should turn to get back on course. (32.36 degrees), because we don't want to miss the party. We got to get to Key West. So hopefully we are sober enough to turn the boat 32.36 degrees, okay? All right. All right, the last question says, how much time has been added to the trip because of this? Assume that the speed remains at 15 miles per hour. All right, so how much time has been added to this trip? Okay, because they're supposed to travel 150 miles, but now, I'm gonna call this E. So find extra time. And we know that their distance, so the distance, well, first they traveled 60 miles, and now they have to go an additional, what is it? 95.84 miles. So 95.84 miles. So 60 plus 95.84. So this gives me 155.84 miles. And the distance to get there was originally just 150 miles, which means that they have to go an additional 5.84 miles. Now, how much time does that add? Well, since we're looking for time, we now use the distance formula. Distance equals rate times time. And the distance we have to go extra is 5.84 miles. We're going at a rate of 15 miles per hour, and we're looking for time. Divide by 15 miles per hour. And 5.84 over 15 gives me 0.39 hours, equal to time. Or better yet, multiply it by 60. And this is going to add, So 0.39 times 60 means this will add 23.4 minutes extra to our trip. That's it. So those extra 5 miles is going to take us an extra 23 minutes. That's it. Whew, that was a lot. Okay. Awesome. So let's see. What is 20 plus 147.64? Okay, cool. One more, guys. That's it. All right. A golfer hits an errant tee shot that lands in the rough. A marker in the center of the fairway is 150 yards from the center of the green. While standing on the marker and facing the green, the golfer turns 110 degrees toward his ball. He then paces off 35 yards to his ball. How far is the ball from the center of the green? Okay. Again, if I drew a diagram, all right. So the golfer hits a tee shot that lands in the rough. A marker in the center of the fairway is 150 yards from the center of the green, whatever. Okay, so we're trying to hit it straight this way. So here is my golfer, and let's see. So center of the fairway to the green. All right. So here's the golfer down here. Or actually, better yet, there's my golfer, and then we're trying to get it to the green. Okay, but then let's see, he hits it, so he shanks his shot 110 degrees. So, well, he turns 110 degrees. So this means that he turns 110 degrees and walks 35 yards to his ball. So this would be the 35 yards. This would be 150 yards. And this angle here is going to be the angle he turned to his ball, which was the 110 degrees. Okay, all we want to know is how far is the ball, because now over here is the ball. There's my golf ball. How far are we from the green? Close enough. There we go. Okay, so let's label some stuff. I'll say 35 is A, 150 is B. The side we want to know is C. Okay, so this one's pretty straightforward. All we have to do is solve for side C. That's it. So, find C, side C. Okay, well, given C squared is equal to A squared plus B squared minus 2AB, cosine of angle C. Plug in what we know. C squared is 35 squared plus 150 squared minus 2 times 35 times 150 times the cosine of 110 times the cosine of 110. Okay, and plug it in. 35 squared plus 150 squared minus 2 times 35 times 150 times the cosine of 110. We get c squared is 27,316.21. Then square root your answer. All right. And he definitely shanked his ball far, because now he is 165.28 yards away. Oof, not good. Okay, awesome. That is all. Okay, that's it. That's law of cosines. We are done.